So, like we were saying, there is no fixed period to observe cyclical variations, but they do occur. Okay, yes, sometimes um, even economies of countries do peak and recess at various, okay, I mean, seasons over some time. Mhm. So this can be observed in various um, data sets. Yeah, so we are saying that examples of data or situations which can lead to cyclical trends or variations are flat war, changes in interest rates, economic depression or recessions, okay, changes in consumer spending, okay. From time to time, we always change our spending behavior, okay. So let's say after about 5 years, what we seem to like, okay, the services and the products we seem to like will not be the same as the previous 5 years, okay. So these are likely to occur. Now, then we also have, okay, I think we've talked about, let's talk about the recessions and the peaks. So cyclical variations, like we said, always have recessions, okay, or what do you call us? The recessions lead to your trough, okay? So we always have our peak observations, and then we have the troughs, which are the lowest observations, okay? And when we are rising from our lowest, that is called an expansion because we are expanding our business, okay? Good. And anytime we are going to the trough, we call that a recession, okay? Good. These are key terminologies you need to know. Now, we also have irregular variations. If a variation cannot be accounted for by any of the patterns of variations we just looked at, okay, then we attribute it to um, an irregular, okay, variation, okay. And some examples will lead to irregular variations are what? Sudden changes in interest rate, collapse of companies, natural disasters, okay, sudden changes in government policies, uh, dramatic changes in stock markets, and so on and so forth, okay. Unrest in petrol prices, the recent even COVID, we saw a dramatic decline in the prices of petrol, and immediately we came back from COVID, we saw another dramatic increase in the prices of what? Fuel, okay, hit to some level which became unbearable and has come down again. So these are irregular patterns. They just take the trend, the true pattern of course, and everything looks uh, out of course. But if you observe it carefully, you still find your trends, your cycles, and your seasons in there, okay, even in the midst of the irregularities. Okay, now we've seen an example already, and this is another, okay, example of irregular pattern. There is more here to look at. Now, so we are saying that these are the four main components we've just looked at. We have the secular trend, we have the seasonal variations, cyclical variations, irregular variations, okay? Good. And now we are going to look at some techniques which are available, okay, to examine the trend in the series or in the data set. Okay, good. The first thing we want to look at is the nature of decomposition. Now, to ensure accurate or reasonably accurate forecasts, the individual components of time series data must be separated out and examined carefully. Okay, and we are saying that to separate or decompose, okay, we first have to determine the trend in the series. Then based on now two models or two assumptions are available, we can either use the multiplicative, okay, assumption or an additive, okay, assumption, okay, good, to find seasonality, cyclical, and random pattern, okay. So additive models assume that the components add up based on an addition, okay, or the components add up. Whilst multiplicative model looks at an interaction, okay, or let me say the products of the various factors or the various variation. So these are the differences in them. One is looks at it on a linear base, on an addition base, and the other looks at it on a multiplication base. Okay, good. Now, once again, let's go a little practical, okay, so that when we get to the practicals, we will not have to be coming back to this again. So I'm going to share my screen in R. So if you look carefully here, okay, this decomposition I did, you can see over here that I've used, you can see D data decompose the time series data using multiplicative, okay, assumption. Now I'm going to do the same thing. So examine the plots carefully. Let me see if I can magnify this a bit. Okay, so this is what we see here. Now I'm going to use an additive, okay, model. I'm going to use an additive model. So let's plot the data. So you see the patterns look very similar, okay? Just that you can see that there was a little variation, okay, in the model, just a little, but the patterns look very, very similar. And clearly, when we use any of these assumptions, we are likely to get good forecast at the end of the day, okay? But that depends on which assumption you are using, whether you are going additive or multiplicative, okay? That's what we are saying here. So there are two techniques available for doing this. Now let's go back to our slide.